Unit 9 Guided Notes Lesson 2. So we're talking about estimating the difference in means. So what we're looking at here is really if you're trying to make a comparison. For example, is there a higher level of zinc concentration at the bottom of a well than at the top on average? Or you're just trying to make comparisons for your averages, but you now have two groups. So it's still talking about the population parameters, but now it's the difference in their means. So you're going to see a lot of similarity to the difference in proportions that we did in Unit 8. And you'll also see some similarity to just the confidence intervals for means that we did the last lesson. So you got to have two independent random samples or possibly two groups in a randomized experiment. So you still have the random condition, but now it's an experiment. So we talked about that way back when we were in school. But we have a test statistic. It's going to be our point estimate for mu sub 1 minus mu sub 2. And we're just going to use x bar sub 1 minus x bar sub 2. So our sample average is the difference of our sample averages is our point estimate for the difference in the population averages. As always, before you can make this confidence interval, you got to check for independence and you got to check for randomness. You got to check all your conditions. They are really familiar. We always start by making sure that we can extrapolate this to some population. So we check the random condition. So since we'll have two samples, not only do they need to be randomly selected, but they should be independent of each other. But you're also going to now have possibly, or two groups in a randomized experiment. So it could just be I have these these big group of people that volunteered for some experiment. I'm going to randomly divide them up into two different groups. So we don't have random selection here, but you still have to have some part of it random to make some type of inference. We still check our 10% condition. This is still to make sure that we have not an issue with sampling without replacement. It's just you have to test it twice now. So we're checking that our first sample size is less than 10%, our first population size, and the same for our second. This one's annoying because it tends to have a lot of writing. And then just like last lesson, we're checking the normal / the large sample condition to make sure that we have something approximately normally distributed. So that was our third condition in lesson 1 too. 1 also. So again, there are 3 ways this could be satisfied, but it does need to happen for each sample. So the corresponding population distribution could be said to be normal. That also could just be the true distribution of the response to the treatment. So it's not a population, but how people respond to, say, Advil or something. Or it could be that the sample size, why is this not moving? Whatever. Or it could just be the sample size is large for both of your groups. But if the samples are small and you don't know the shape of the population distribution, then just check your graph to look for skewness or outliers. So an example of checking those things, example 1, college student wants to compare the cost of 1 and 2 bedroom apartments near campus. She collects the following data on monthly rent in dollars for a random sample of 10 apartments of each type. So I do have on here some of it already filled out for laziness purposes, but I'm going to go ahead and define mu sub 1 and mu sub 2 so that the order of our difference is already stated. And by I mean the problem already has that stated. Mu sub 1 is the true population mean monthly rent of 1 bedroom apartments near campus, where mu sub 2 is the same thing but for 2 bedroom apartments. So if I'm going to check those 3 conditions, the first condition is the random condition. And so when I read through this, where was it? So it is a random sample of 10 apartments, and you do need to mention that they are independent random samples. It's a small technicality, but it does need to be stated. So of 10 one-bedroom apartments and 10 two-bedroom apartments near campus were selected. The 10% condition is checking the size of your samples. So we can assume that 10 is less than 10% of all the one-bedroom apartments near campus. And the other sample size of 10 is also less than 10% of all two-bedroom apartments near campus. So I'm putting it in context, but so you didn't have to sit there for a full minute watching me write something, I went ahead and wrote it out in advance. And then the last one, the normal large sample. The sample sizes are small, which is problematic. We can't just jump to the easy check of this condition yet. But if I look at the dot plots, which I created, so I just looked at the given data I sketched the dot plots. They are not perfect, nor do they need to be, but I do need to actually show that I've looked at these dot plots. And when I look at them, there's not really any strong skewness here. I don't see any outliers. I don't see where all of the dots are down here and then a couple at the other end. That's not what I'm seeing. So because we don't have any dramatic skewness, we don't see any dramatic outliers, then we can go ahead and say we've satisfied this condition, and we would be able to go ahead and proceed in making a confidence interval for the true difference in the population means for these two monthly rentals, I guess.